What's the endogenous variable?
Price.
Price, yeah. So we don't have a good estimate of price. We know it's endogenous, it's not exogenous, so take the problem variable, so Houseman test. Take the problem variable and regress it against all of the independent variables from both of our equations. So it's going to be gamma 0 plus gamma 1 price of our competitor plus gamma 2 wage plus gamma 3 price of cheese, and we're going to put plus squiggly. We'll use our same notation we used in the PowerPoint. So we're going to run that. We're going to save the error term, which is squiggly hat. So let's run that. Regress our problem variable. Price competitor, wage, cheese. All right. This is called the reduced form equation. We're going to save the residual, so let's just call it error, and R for residual, predict. So predict error. Then we're going to take this predicted error, squiggly hat, and put it into our demand curve and see if it's statistically significant. Regress Q, P, comp, error. Okay. Coefficient is 168. T-stat of 8.5. It's statistically significant. Remember, it's an error term. It's not supposed to have any valuable information, yet it's apparently predictive in our demand equation. So this is our Houseman test is really just a t-test on the error term. It appears we have some endogeneity. So we're going to use instrumental variable regression. Now we actually have an interesting problem here. Remember, our instrument needs to satisfy two things. In this context, it's pretty easy, but it needs to be in the supply equation. That's not in the demand equation. And we have two things that are in the supply equation. We've got the wage and the price of cheese, both of which should affect price, right? If wages go up, then the price of pizza is probably going to go up. If cheese goes up, then the price of pizza is probably going to go up. So we're going to satisfy that. We satisfy our relevance. These are relevant instruments. And then our exogeneity condition or orthogonality condition is that they don't belong in our original equation of interest. So let's use both. Let's try both as instruments individually. Okay. So let's go back to our regression. So here's our demand. Here's our ordinary least squares demand curve that we know suffers from endogeneity because we just ran a Houseman test, and it tells us it does. According to this regression, for every $1 increase in price, we're going to sell 34 fewer pizzas per month, or vice versa. For every $1 decrease in price, we're going to sell 34 more pizzas. So that gives us one estimate of our demand curve. We're going to run instrumental variable regression. Instrumental variable regression. So the command for that is IV regress. two stage least squares, 2s ls, and then we run our model. Here's quantity. Here is comp, the price of a competitor's product. And for our instrument, we're going to instrument price with wage.
So what is that doing?
So this is telling me what our instrument is. Our instrument for price is going to be wage.
An instrument is we're shifting, right?
Is the thing that shifts the supply curve that allows us to identify the demand curve.
Okay.
So instead, the instrument is, we literally specify the instrument as just P equals that thing. Any questions? Let's see what happens. Be careful, sometimes this thing will go up. All right. We get a different coefficient. So remember what it's telling us before. Before it's telling us our ordinary least squares regression, our regular regression, is telling us that for every $1 increase in price, we're only going to sell 34 fewer pizzas. Our instrumental variable regression is telling us now for every $1 increase in price, you're going to sell almost twice as few, right? Almost 60 or 58 fewer pizzas. Not 34 fewer pizzas, but 58 fewer pizzas. So that's a pretty significant effect. What'd you say? Man, it's a pretty big effect. This is why nobody liked those demand for wines, because everybody knew there was a problem and they couldn't find a good instrument for, a valid instrument, a strong instrument for wine, even though the obvious one, grapes. So they tried glass, they tried, what were some of the other ones? What'd you say?
Cork.
Cork, yeah, I guess cork, but I think you got a screw top. So they tried all kinds of different things in there. Never. But think about glass. Glass is used for 1 billion and one windows, cars, glasses. The price of glass and wine is not going to be that highly correlated. You know, even if I don't know what those. I know none of those came out very strong. But you know, even if you think about the cost component of glass as opposed to as an input into wine, it's got to be one of the lowest cost things is glass. So it's going to be such a small fraction.
So does that command, is that, so we decided to use an instrument to move along the supply curve, so it's kind of getting rid of points that could be supply curve points? I guess I don't understand what the command is actually doing.
It's literally doing what we kind of drew up here. It's by using our instrument, it's shifting the supply curve so that we get this demand curve instead of, because really what we're getting, we're getting this demand curve instead of that demand curve or some other demand curve.
Okay.
So it's supposed to give us a more accurate picture of the sensitivity of price, of consumers to price. It's going to change our elasticities. It's going to change our optimization. Because remember, as that demand curve shifts, we can. Because if you think about what we have here, it looks like consumers aren't that responsive. So our demand curve is saying every $1 increase in price, we're only going to sell 34 fewer pizzas. So it looks like demand is relatively inelastic. So if you think about this, here's Q0, here's P0. So when we increase price, yeah, we're going to sell less, but this is only 34 pizzas for every $1 increase. Assume this is $1. Right? We're only going to sell 34 fewer pizzas. When we run the instrumental variable regression, it's saying, wait a minute, that demand curve looks more like that. So this is demand OLS, this is demand IV, instrumental variable regression. And it's saying, now, when you jack up price by $1, you're not going to sell 34 fewer pizzas, you're going to sell 58 fewer pizzas. consumers are a lot more sensitive than your original estimates predicted. And notice it's going to affect, right? If you're trying to optimize price, if you're trying to figure out the optimum price, I mean, look at that. Just kind of go from backwards. Let's say you wanted to figure out the optimum price for Q2. If you're using the OLS regression, where's that going to be? Where's the optimum price to sell Q2? Way high, exactly. I didn't even draw it high enough.
It's the most expensive pizza in the world.
Exactly. That's your optimum price. So if we were doing that price optimization like we did in 580, it would be telling us, yeah, you could charge $700 for a pizza, boom, you're going to sell them all. Yeah, we're saying, wait a minute. We don't like that estimate. You know, you can't charge $700 for a pizza. You got to charge $20, $30. Pizza's expensive. Good pizza's expensive. Like Mary's Pizza. I love Mary's Pizza. And that's like $30 for a pizza.
Too much.
But it's worth it. There's nothing worse than bad pizza. Make sense? So the ramifications of this are huge. And like I said, you know, forecasting, price optimization, everything is all about demand. When we're forecasting demand, we're saying the opposite. Okay, at this price, how much can we expect to sell? Well, that's a forecast. And if every demand curve is subject to endogeneity, then we got to deal with this on a daily basis. Let's do something else. Let's use wage. I'm sorry, we used wage. Let's use the price of cheese as an instrument, because we have two choices here. So this is easy because we can just reuse this command. So instead of wage, I'm going to put, oops, cheese. Did I spell that right? Yeah. I'm going to put cheese. So we're going to run again a two-stage least squares regression, but we're going to use cheese. And cheese makes perfect sense, right? The first thing you think about pizza is, boom, cheese. So price of cheese goes up, yeah, price of pizza should go up. What happened? The first one had a coefficient on price of 32. Every $1 increase in price, we sold 32 fewer pizzas. The better IV regression gave us a coefficient of 58, but we used another IV regression using a different instrument, and it gives us a coefficient of 11, which means that demand is even less sensitive. It's even steeper than we thought. The problem is we never tested the relevance of these instruments. We just kind of theoretically said, well, are wages, is the wage of pizza makers and the price of pizza correlated? Yeah, absolutely. Is the price of cheese and the price of pizza correlated? Sure. But we never tested it. Just like here, we could have had a really weak correlation. So one way to test it is just to regress it. Is to regress wage on price on wage and price on cheese and see how strong that correlation is. Another kind of rule of thumb is, remember, two-stage least regression goes in two stages. The first one is they construct the instrument, and the second one is then they use that instrument in our regression. So if we go to our regression command, and we use the word first, it'll show us actually both stages of our two-stage regression. So the first stage, remember, we called that the reduced form equation. Where we have the exogenous variable from the demand equation, competitor's price, and cheese. And notice the coefficient on cheese is negative, which is kind of strange, which means that the price of cheese goes up, the price of pizza goes down, but it's not very statistically significant. It's close, 1.88, but it's not that strong. The rule of thumb for the first stage regression is that you want your F statistic to be greater than 10. It's kind of a rule of thumb that I follow today. Notice the F statistic up there, it's only 1.95. It's not even close to 10. So the problem is, yeah, we got an instrument, yes, it's correlated, but it's not very strongly correlated. A weak instrument, this is important, a weak instrument is worse than no instrument at all. In other words, our OLS regression is probably more accurate than our instrumental variable regression with a weak instrument like the price of cheese. Let's do that same thing, but let's use the first option with our wage. Okay. Notice the coefficient on wage is positive, which makes sense this time. Wages go up, price of cheese goes up. It's statistically significant. It's not marginal this time. It's well over 2. And notice our F statistic for our first stage is greater than 10. So we've kind of satisfied our condition for relevance. Just because it makes sense doesn't mean it's a valid instrument. And that was the problem with the wine industry. Here, wages were a stronger instrument for price than the price of cheese is. Weak instrument is actually worse than no instrument at all. And that's what was happening here. Oh, very, very weak instruments, glass, and I think someone tried to use wages of grape picker, farm worker, whatever. But weak instruments end up with worse results than ordinary squares. So. What if what? What if we use both? Two instruments are better than one. In other words, having more things that shift that supply curve, that account for shifts in the supply curve, are better than having fewer things. So if you have two instruments, then use both. And you can see now that using both instruments, notice that both wage and cheese are now positive. Cheese wasn't positive before, it's now positive, and it's statistically significant. They're both statistically significant. Notice our F-stat using both is well over, I think it was, what was it before, 18? Now it's 29, almost 30. And look at our coefficient. Our coefficient started out at 34, I think. Then it went to 58. Now it's 73. This is the better estimate because it's the stronger instrument. So again, not only, all right, we're getting this thing even flatter, meaning consumers are even more sensitive than we thought they were. So not 58, it's for every $1 increase in price, we're going to sell 73 fewer pizzas and not 58, and very well not 34, and absolutely not 11, which was the bad instrument, the weak instrument. And not everybody necessarily, this is why I use this example, not everybody agrees that weak instruments are necessarily bad. So one of the professors here in my department, the economics department, always says, well, it doesn't matter if it's a weak instrument, just use it anyways. It's not quite right. I won't tell you who it is because I'm on camera. But as soon as the camera goes off, I will.
What do the coefficients on wage and cheese mean?
It's just the for this, it's just telling us that we're really looking at how strong of a correlation between wage and cheese are with the price of pizza itself. So kind of literally, it's saying that for every $1 increase in wages, the price of pizza will go up by $1.50. And for every $1 increase in the price of cheese, the price of a pizza will go up by 7 cents. But remember, it was negative before. Cheese was negative before. And it was marginally significant. Now it's fully statistically significant. So we're more comfortable with these. We're a lot more comfortable with these results than we were with the results individually. And I think we have more confidence in our estimate here in our price coefficient. Again, this kind of emphasizes the importance of this stuff. Just for fun, let's do the supply curve, because we don't normally estimate supply curves. Supply curves have to do mostly with cost, because it's the cost of production that determines those supply curves. But let's do it anyway. Because remember that when we run, well, we can run our supply curve. So our supply curve would be quantity, price, wage, and cheese. So these are the factors that belong in the supply curve. Of course, we have to put reg in there. This is the hard part of econometrics. I need to put reg. All right. Supply is upward sloping. You get a positive coefficient. That's probably pretty good. You know, everything here is reasonable. Price is positive for supply. It should be positive. So wage is negative. So as the price of, I'm sorry, as wages go up, we're going to sell fewer. We're going to supply fewer pizzas, which makes sense. It's going to shift back. And as the price of cheese goes up, it's going to shift the supply curve back also. So both of those are negative. Everything looks fine. Everything looks reasonable. Let's do a Houseman test. Remember, the Houseman test is take our price, our endogenous variable. So we know this suffers from endogeneity. And that's kind of what we need to remember is we know there's endogeneity. We just need to see if it's to such a degree that it's problematic, and then can we fix it? And so let's do the Houseman test. It's the same test, by the way. So we're still going to take our problem variable, regress it against all of the other variables, save the error term. So we already have error. We already have squiggly hat. So we can just kind of do that now. And we can put error in here and see if it's statistically significant. No. So we know there's endogeneity inherent in estimating both supply and demand curves, but in this particular case, the supply curve doesn't seem to be suffering from endogeneity to the same degree that the demand curve was. So we can still run an instrumental variable regression and see what happens, and we will. But we don't expect to get that big of a change because we don't see, at least according to the Houseman test, we don't see signs of endogeneity, which is what we're looking at when we look at that error term. So let's run, here's our model. So we need something in demand that's not in supply that'll shift demand, allowing us to trace out the supply curve. In this case, we only have one option. We got the price of a competitor's pizza. So we use IV regress quantity. We need to instrument price with, what do we get instrument price with? What'd you say?
Competitor price.
Competitor price, comp, exactly. Competitor price. Let's do look at the first stage. Oh, I forgot to put two-stage least squares. Two-stage least squares. That's relatively new, by the way. Before it used to be, you didn't have to put that. Okay, so let's check out our first stage, make sure we got a valid instrument. Let's see, competitor's price is positive but insignificant. Our F-stat is greater than 10. So we got a valid instrument, even though competitor price is not necessarily statistically significant. I don't remember what my coefficient was. They're different. They are different. So the coefficient on price from our two-stage least squares is 193. So for every $1 increase in price, suppliers will supply 193 more. From our ordinary least squares regression, it looks like for every $1 increase in price, they'll supply 102 more. I think the difference percentage-wise is not as great as the demand curve. Remember that coefficient almost doubled, right? 34 to 78? Is that right? Yeah. It's more than double, actually. Was it 78?
It was 58.
58, okay, so it almost doubled.
double.
Yeah, so almost double. So yeah, 34 to 58, I mean, that was a huge change. Here we're getting a small change. Even though, you know, price of competitor was, again, the first stage kind of satisfies our criteria for the F statistic rule of thumb. It was greater than 10, yeah, but we know that competitor price was it marginally significant? Or was it competitor price is 1.37, yeah, it's really not that strong of an instrument. Any questions? Like I said, real technical, but yeah, this is endemic to what we do. It is what it is. You can't really get around this. It's just a problem. So let's just kind of wrap that up. So this is what we did. We got 34. We did a test for endogeneity. Did the Houseman test. So there's our Houseman test, step 1 and 2. We stuck the error term into our structural demand curve. It was positive and significant, so we said there was endogeneity. Yeah, there we go. We can stick it into supply. And yeah, it was statistically insignificant. There was small t's now. I'm sorry, the p-value. Two-stage least squares. Technically, you kind of construct the instrument, and then we use the instrument in place of our endogenous variable. And notice the instrument is essentially going to be the same, whether it's supply or demand. If it's demand, we got these two instruments. If it's supply, then we got the one instrument. But the instrument itself is going to contain all three of those. And we saw that from the first stage of our two-stage least squares regression. And then we plug in that instrument into our supply and demand curves. So this is for demand. Again, we saw 34 was the ordinary least squares regression. 58 when we used wages as an instrument. 11, which is really bad, when we use cheese as an instrument, which tells us it's better to use ordinary least squares than a weak instrument. When we use wage and cheese, we're up to 73. And we think that's the best estimate. You can actually do this by hand, and this is not necessarily a bad exercise. In other words, instead of using the IV regress command, construct the instrument, predict it, use price hat instead of price in your ordinary least squares regression. So that's what I mean by do this by hand. I mean, literally construct the instrument. Yeah,
Not by hand painted.
Yeah, I want to
It's
see
like, wow,
pencil and
that's
paper, and I want to see all the math done. But construct your instrument by hand and use ordinary least squares. Now, technically, you're not supposed to do that because you're going to get different. You can get different standard errors. So, yeah, notice the R squared is different too. So you're not supposed to do it by hand. You're going to get the same coefficients, but the standard errors will be different, although they're not showing up as different here. They're still significant, but it's a good exercise just to remind us what it is we're doing. And here's the two estimates of supply, which are pretty close, pretty similar. Properties of two-stage least squares estimates. So in small samples, they're going to be biased, but still going to be biased. But as the sample sizes get larger, our two-stage least squares estimates are going to approach the true values that we're trying to get to. The small sample bias will be opposite of the bias in OLS. So in OLS, we know that if the error term and the endogenous variable are positively biased, are positively correlated, you're going to get positive bias. The small sample bias will be negatively biased. That's underestimates of U. Again, if the fit of the reduced form equation is poor, then two-stage least squares doesn't work very well. This is that first stage of the regression. So if we get a weak instrument, then we get bad results. Our coefficients can be badly biased. And here's our rule of thumb. Look at the first stage of our two-stage least squares regression. If it's 10, if it's less than 10, then it's weak instrument. And if it's greater than 10, then we got a pretty decent instrument. It's exactly 10. There may be some problem with multicollinearity. Remember, multicollinearity, we said, is the fact that our independent variables are going to be highly correlated with each other. This is true by definition because literally, when we construct our instrument, remember the instrument is literally a function of the other independent variables. So almost by definition, we're introducing multicollinearity, but we're getting rid of one problem, but we may get stuck with another one. It could be. It doesn't necessarily have to be a problem, but it could be a problem. Yeah, so everything's more accurate using two-stage least squares. Our t-tests, R squared,